What's up, everybody? This is Tech G back with another video to help you successfully pass the CompTIA Security Plus 701 certification exam. So let's get into it. In this video, you're going to learn about technical implications, documentation, and version control. All right, so let's talk about technical implications, and this refers to the potential consequences or effects of a technology-related decision or event in the cybersecurity landscape. Technical implications could involve alterations to network infrastructure, modification to security protocols, or the need for additional server capacity following the implementation of new software or systems. It is important to ensure that you understand all technical implications of any new or existing system to ensure that you can maintain functionality and security for that system. All right, next let's talk about allow lists, also known as white lists. And these are lists of approved inputs a user or machine can enter on a system. Using an allow list, this is an easy and safe way to ensure well-defined inputs such as numbers, dates, or postal codes, because it allows you to clearly specify permitted values and reject everything else. With HTML5 form validation, you get predefined allow list logic in the built-in data type definitions. So if you indicate that a field contains an email address, you have ready email validation. If only a handful of values are expected, you can use regular expressions to explicitly include them on an allow list. Now, using an allow list, this gets tricky with free-form text fields, where you need some way to allow the vast majority of available characters, potentially in many different alphabets. Unicode character categories can be useful for allowing. So, for example, only letters and numbers in a variety of international scripts. And you should also apply normalization to ensure that all input uses the same encoding and no invalid characters are present. An allow list needs to be continuously updated as the company works with new applications and removes old ones, and a lot of resource time is required to maintain it. All right, next let's talk about block lists and deny lists. So in the context of input validation, a deny list, this is a list of specific elements, characters, or patterns that are disallowed from being entered into a system. When approaching input validation from a security perspective, you might be tempted to implement it by simply disallowing elements that might be used in an injection attack. So for example, you might try to ban apostrophes and semicolons to prevent SQL injection, parentheses to stop malicious users from inserting a JavaScript function, or angle brackets to eliminate the risk of someone entering HTML tags. Now, limiting or blocking specific inputs is called block listing or deny listing, and it's usually a bad idea because a developer can't possibly know or anticipate all possible inputs and attack vectors. And block list-based validation is hard to implement and maintain. So let's say that you want to use deny lists despite their issues. These lists are an additional maintenance point. And you need to understand that these lists can potentially break things, and your upper layer programming should not depend on deny lists to stop attacks. All right, next let's talk about restricted activities. And these are specific actions or operations within a computer or network system that are limited or prohibited to maintain cybersecurity standards. And these limitations are often defined through allow lists and deny lists, which, as you've just seen, explicitly outline what is permitted and what is not. So for example, restrictive activities may include accessing specific system components or downloading unapproved software. Now, clearly defined restricted activities are crucial for upholding secure environments and effectively communicating IT systems' acceptable use to internal and external stakeholders. These restrictions are commonly introduced during the employee onboarding process through key documentation like acceptable use policies. In change management, access to critical areas like the production environment and change management software is typically restricted to authorized personnel only to ensure that only qualified individuals can make or approve changes, reducing the risk of unauthorized or harmful modifications. All right, next let's talk about downtime. So downtime, this is time during which a system, network, or software application is unavailable to end users or it's completely offline. Downtime can be scheduled, such as during maintenance windows, as discussed earlier, or it can be unplanned, sometimes due to technical problems or even cyber attacks. Acceptable downtime might be for critical system patching or planned upgrades, and a common standard of availability is 99.999%, which is is commonly referred to as the 5 nines of availability. Then we have the 2 nines, and this will be a system that guarantees 99% availability in a 1-year period, allowing up to 1% downtime or 3.65 days of unavailability. Now, you might find that if you leverage third-party services, you need to ensure that their systems match or exceed your published service level agreements or SLAs. You may need to implement a change if there is a misalignment between the SLA you have with your clients and what any third-party services provide to you. Unplanned downtime, this can disrupt business operations, negatively impact employee productivity, and potentially result in data loss. IT professionals are often focused on reducing downtime, which is crucial in cybersecurity and IT management. It's essential to have strategies to address issues when they happen and minimize the duration and impact of unplanned downtime. Now, planned downtime is needed to conduct IT maintenance activities, software installation or upgrades, and other activities on required non-active systems. You might need to upgrade a firewall on the network, which could require turning off the current system. And to prevent making the network and end users vulnerable, you would schedule downtime, typically during the off hours or non-peak time, to replace the network devices. All right, next let's talk about a service restart. So in your role as an IT or security professional, one task you'll likely encounter is a service restart, which involves halting and then reactivating a system service to implement updates, patches, or configuration changes. This process is similar to turning off a car that's encountering a minor glitch and then restarting it. Now, the key aspects to note here is to understand the potential implications of a service restart, such as a momentary disruption of service. You need to ensure that potential users of the system are aware of any time impacts. You also need to thoroughly map the connections the services might have with other systems. You don't want to restart a service connected to a critical database that could make the organization or its data vulnerable to attacks. To minimize disruption to users, it is crucial to ensure that this action occurs during a predetermined maintenance window. All right, next let's talk about an application restart. So software application restarts are sometimes necessary procedures. An application restart is like a service restart, but it is concentrated on specific software applications. An example you're no doubt familiar with is an app on your phone freezing and needing to be restarted to function correctly again. Application restarts are common in IT and cybersecurity, and you may often need to restart applications or systems to load patches and enforce updates. Again, communication and coordination with the stakeholders of the application is critical. All right, next let's talk about legacy applications. So in the course of your career, you will likely encounter older systems still running on the network for a variety of reasons. Handling legacy applications, which are older software programs still serving a critical function in an organization, this is a typical duty that you more than likely will encounter. And legacy applications, they allow you to leverage uncommon technology, and that can be fun, especially if the original engineers are still working on the system. However, dealing with legacy applications often requires understanding older technologies and the specific nuances associated with them, which can be especially challenging if the older engineers have moved on. So it is important to understand any connection the legacy application requires to function. You might find limitations in the types of operating systems the organization must maintain if the legacy application requires a certain OS to run properly. All right, next let's talk about dependencies. So when working with software components, grasping dependencies is crucial. Dependencies refer to the relationships where one software component or service relies on another to function correctly. So think of the roof on a house. The roof may be supported by large beams of wood or stone columns. If you were to remove any of the beams or columns, you would jeopardize the integrity of the roof. Understanding dependencies is critical for troubleshooting issues, managing updates, and implementing changes in the IT environment. And services, newer applications, and legacy applications are all likely to have critical dependencies that you need to understand before you do any maintenance on them. All right, next let's talk about documentation. So an essential part of any IT or cybersecurity professional's role is the creation and maintenance of documentation. The documentation is written material that provides information about a system or a process. It might include user guides, technical specifications, or system descriptions. And documentation may also be written for specific products. So for example, you got product documentation and user guides, or for specific processes such as installation installation instructions, uninstallation guides, and patching processes. And documentation can also include policies, procedures, standards, and guidelines. And many organizations have their own security policies that cover critical security topics such as change management and change control policies, information security policies, acceptable use policies, and business continuity planning/disaster recovery policies. And good documentation, this ensures a clear understanding of system operations, making it easier to train new staff and troubleshoot issues. And it is often a good idea to begin with documentation when trying to ascertain any dependencies software or system may require for operations and to map any dependencies. Next, let's talk about updating diagrams. So in the ever-evolving landscape of your IT environment, the process of updating diagrams, this plays a vital role. Updating diagrams, this is the process of editing current diagrams of systems or networks and inserting any changes that have occurred since the diagrams were originally created. And as a best practice, you should ensure strong version control and put a version control number on every diagram. In diagrams, they can be visualized as maps or blueprints of your network or flow charts of a process. In updating diagrams, this ensures that everyone has an accurate and current picture of the systems. This clarity can significantly enhance troubleshooting and system upgrades. A good configuration management process, this helps to prevent small or large changes from going undocumented. Undocumented changes, this can lead to poor performance, inconsistencies, or non-compliance, and can negatively impact business operations and security. Poorly documented changes, this adds to the instability and downtime. So having good network diagrams and well-written and up-to-date documentation is crucial and allows you to not only troubleshoot problems, but also respond quickly to security incidents. All right, so let's talk about updating policies and procedures. So one crucial responsibility you will shoulder is updating policies and procedures. In the cybersecurity landscape, policies are the rules governing how IT systems are used and secured, whereas procedures are the specific steps required to implement these rules. It's worth noting that policies and procedures are directive controls that help communicate expectations to an organization. You must continuously revise policies and procedures to align with technological advancements, environmental shifts, or system modifications. Doing so ensures smooth, efficient, and secure operations of your IT infrastructure. Also, you should generally pay attention to the legacy applications that require unique user instructions. So for instance, a legacy terminal application that is used to manage network interfaces could inadvertently expose privileged access if a policy changes, but the corresponding procedures are not updated. All right, next let's talk about version control. So understanding and effectively implementing version control is vital for IT and cybersecurity domains and extends into areas like documentation. Version control is a system that records changes to a file or a set of files over time so that you can recall specific versions later. It allows you to track modifications, pinpoint when and by whom changes were made, and if necessary, revert to an earlier version. So for example, in modern IT environments, code is often checked into a version control repository like GitLab or GitHub. Each change is integrated and tested with the rest of the software system. Organizations that lack proper version control face challenges in tracking bug fixes and security patches. Similarly, vendors and software providers that lack appropriate version control make it difficult for consumers to correlate, triage, and patch security vulnerabilities. Proper version control is a best practice and a necessity for maintaining a secure and efficient operational environment. In failure to maintain version control, this can lead to confusion and potential problems. So consider, for instance, a potential issue when a team member says, "Aren't we on version 2.3?" only to discover that the system was updated to version 4.0 weeks ago. Effective version control not only aids in managing changes and troubleshooting issues in a collaborative environment, but also plays a crucial role in communication updates to policies and procedures throughout an organization. So it is an essential component of any well-run organization. All right, so that was my video where we talked about technical implications, documentation, and version control.